So again, we have this equation. For what reason? We'll see later. We have this equation, and we want to solve it for A and B. Ultimately. To do that, we're going to need to put everything over common denominator. And so we can do, okay, first of all, we see that the x plus 3 is the same here as it is here. X minus 2 is the same here and here. So the common denominator is x plus 3 times x minus 2. To express this with that denominator, we take the a over x plus 3 and multiply by x minus 2 over x minus 2. And we did this recently, so this should be fairly familiar. Okay, we don't do anything over here because we've already got the same denominator. What do we do to the b over x minus 2? Take a minute and see if everybody knows how to do that. And if you want to chime in through chat, just say what we have to do. That would be great. Okay, we did pretty well here. To get the denominator x plus 3 times x minus 2, we'd have to multiply this denominator by x plus 3. We've got to multiply by something over x plus 3. But we can't multiply by just anything without changing it. But if we're multiplying by x plus 3 over x plus 3, we haven't really changed this. We've just changed the form of this term. And this is equal to this. Because the x plus 3 will divide out back here. Okay. Well, now I'm going to write this as I can multiply numerators and multiply denominators. And over here, I can multiply numerators and multiply denominators. And that's a pretty obvious step. And then what? Well, since I've got the same denominators here and here, I can add the numerators and put them over that denominator. So I have a times x minus 2 plus b times x plus 3 over my denominator, which is x plus 3 times x minus 2, which is 1 over 3 times x minus 2. Well, these two fractions have the same denominator, so the numerators have to be the same. So a times x minus 2 plus b times x plus 3 equals 1. Now, what are we going to do with this? Well, let's try it again. We can distribute here. We get ax minus 2a plus bx plus 3b equals 1. And we can write, well, we can put the x's together. We can write this as ax plus bx minus 2a plus 3b equals 1. The x terms together here. And now we can write a plus b times x plus 3b equals 1. Now, what's this tell us about A and B? There's actually only one set of A and B values that makes this true. Think about it a minute. Whatever A and B are, if you add them up and multiply by X, you're going to end up with an X term. There's no X over here. Okay. How's that going to be? That's only going to be if A plus B is 0. Okay. We can actually write it out a little more explicitly. One is the same as 0x plus 1. Since we've got an X over here, kind of helps to have a 0x over here. It doesn't change the equation. It just tells us pretty explicitly that A plus B has to be 0. If A plus B was anything but 0, we'd have an X over here, and we don't. A plus B has to be 0. No X is on the right. And then what's that leave us? Negative 2A plus 3B has to equal 1. Because 1 is what we had over here. Okay. Now what's this? This is a system of simultaneous equations in A and B. Can you solve this system? Go ahead, I'll give you a couple of minutes and I'm going to ask you to solve this system. You do it by elimination. It's rather easy to do. Let you think through that. Okay. If I multiply this equation by 2, I'm going to get 2A plus 2B equals 0, right? And then if I add the equations, I'll have a 2A here and a negative 2A here. That gives me my A. So, call this equation 1, call this equation 2. Okay. 2A plus 2B equals 0, then equation 2, negative 2A plus 3B equals 1. We add these equations up. The A's go away. We get 5B equals 1. So we can use 1/5. We substitute that into the first equation. I'll substitute that here. That'll give me the equation. A plus 1/5 equals 0. Subtract 1/5 from both sides, you get A equals negative 1/5. Okay. So we've concluded that 1/5 over X plus 3, negative 1/5 over X plus 3, plus 1/5 over X minus 2 equals 1 over X plus 3 times X minus 2. Now, you might not fully appreciate how important it is to do this. Okay. But if you take a little bit of calculus, it's going to be very helpful to you. I kind of question whether it's necessary to do this in a pre-calculus course, but it's in our syllabus, so we do it. And it'll be on the test. Okay. I think anybody who does well enough in pre-calculus to succeed in calculus can figure this out very quickly when they get to calculus. Still, I can hurt you to know it could be helpful. Another thing is not everybody gets calculus, not many applications of this outside of calculus. So the reason I kind of question whether we really do that in this course. But this course does say pre-calculus. Supposed to prepare for calculus. Okay, let's do another one. Let's do let's do this. Okay. Now copy this down because I'm going to want to move it out of the way so you can look at the solution to what we just did to remind yourself of the steps. They're kind of prompting every once in a while. You got it? Okay. Now I'll also write it down over here. Just move it out. That's a little hard to read there, especially since so tell me in chat if you have trouble. Seeing the expression. If you want me to type the expression into chat, if you can't see it, please let me know. And I find that we're still recording because I was busy with chat. Okay. Okay, I'm not going to run through all of the solution right now, but I will take it up to this point. And then give you a couple more minutes to figure out what your simultaneous equations are if you need to do that. Okay, so you could have a over 2x plus 1 multiplied by x plus 4 over x plus 4. You have to multiply by 1 to avoid changing the value of this expression. And x plus 4 over x plus 4 is 1. And the x plus 4 here will multiply the 2x plus 1 and make this into a fraction with the same denominator you have over here. Read it all to you. And then you do this analogous thing with b over x plus 4. If you want to get the denominator 2x plus 1 times x plus 4, you got the x plus 4. You need the 2x plus 1. Of course, then you better have it in your numerator too. So they're just multiplying by 1. So you haven't changed the value of this expression. We now multiply the numerators here and here to get a times x plus 4 over 2x plus 1 times x plus minus b times 2x plus 1 over plus 4 times 2x plus 1. And of course, this is the same as this, but I have a commutative block in different orders, but we understand that I'm not seeing much trouble related to that sort of thing. So here we have it. Then we use a distributive law. And I'm actually going to kind of skip a step. I know that I can combine the numerators, and at the same time, I'm going to use the distributive law. And writing it all out, I have this. Now that I have both fractions expressed, both fractional expressions, if you wish, expressed with the same denominator, a single fractional expression here, a single expression here, I know that the numerators have to be equal. So we have this. Being careful, I've actually removed the parentheses on this term, and I'm going to get a negative for both the 2bx and the b. Be careful about all your signs, all your bookkeeping. Okay. Now, what do we do? Well, at this point, we got something completely analogous to this. Now we've got an x plus 3 here, instead of just a single number 1 over here, right? But that's not going to give us any proof. What we need to do in both cases is group our x terms and group our numericals. So we have ax minus 2bx plus 4a minus b equals x plus 3. We factor out the x and we get a minus 2b times x plus 4a minus b equals x plus 3. This is going to give us two simultaneous equations. So if you don't have the two simultaneous equations, write this one down and see if you can tell me what the two simultaneous equations are going to be. Okay. What are your two simultaneous equations? Well, this is what you're multiplying by x. And of course, over here, for you multiplying by x. So that's 1x, right? So this in front of x has to equal whatever's in front of x here. So this has to equal 1. So we get ax minus 2b equals 1. Then we have 4a minus b. Doesn't have an x on it. That's got to be equal to whatever doesn't have an x on it over here, which is 3. So we have 4a minus b equals 3. Now this is a system of two simultaneous equations and two unknowns. A and b. So can we solve this system? Okay, everybody should be pretty adept at solving simultaneous equations by this point. But let's see, I call this equation 1, call this equation 2. What am I going to do to match up the variable? Well, I could multiply the first equation by -4, which would give me a -4a, match up with a 4a. That's easy enough. I think even easier, multiply by -2, which would give me a +2b here, right? Added -2b2 is smaller than 4. It really doesn't matter. It's easy either way. But I'm going to do it with a smaller number. So I'm going to do equation 1. And then -2 times equation 2. Okay. And when I write them out, I'm going to have AX minus 2b equals 1. Then I'm going to have -8 and I don't know why. Okay, I've got an AX and there's no X in this equation. I'm not sure why. I must have been looking at that when I wrote it down and then being little carrots. Be just A minus 2b equals 1. And then we have -8a plus 2b equals -6. Now, hopefully, you can read that okay. But just to be sure, let's zoom in a little closer. Okay, this thing has a mind of its own. So here are the equations. Equation 1 and 2 here and here. 1, -2 times equation 2 here. Now that's still a little hard to read. So I'm going to zoom back out. Up. Now a little more. I can see my screen. Up. And then down a little bit and in. I'm going to write these two equations up here so we can see the solution. I didn't leave myself much room, but I should be able to see this because here I have the two equations. When I add them, these go away. I end up with -7a equals -5. So the a is 5/7. Now, if I plug that in here and solve for b, I'm going to get 5/7 minus 2b equals 1. And that's going to give me b equals 1/7. Okay. And make sure 5/7 minus, looks like b ought to be -2/7. Okay. Still not leaving myself quite enough room. B is -2/7. And we can write all our. Well, you're going to see all this in the open math. Wanted to work through the algebra steps a couple of times. Okay. I think most people could profit from another example, which we're going to do one more, except this time Not trying to be mean to you or anything, but I want to do one that has a quadratic expression in the denominator. Think about finding words for this. No, okay, I'm not going to find a little bit of words for this. I'm going to use a whole lot of board space. And let me find the board here. Okay, that should do. Okay, hang on. Okay, let's take this. And so be, sorry, be an AX plus B on this. And then we'll have a C here. So we'll have an A, a B, and a C. We're going to get three simultaneous equations and three unknowns. And I'll observe that this isn't going to factor. This quadratic isn't going to factor. Okay, that's important. Not going to factor because if you use a quadratic formula from that expression, you're going to get a negative under the discriminant. So this thing can't equal 0. If you could factor it, it would have values where it equals 0. So this is an unfactorable, irreducible quadratic expression. Not changing anything. Let's see what another story. So first step, what are you going to multiply the remaining denominator by here? What are you going to multiply by here? Make sure your denominator equals this. You're going to have ax plus b over x squared plus 2x plus 4 times x plus 3 over x plus 3. So when you multiply your two denominators, you're going to get the common denominator. And over here, I'm going to c over x plus 3, in order to get this denominator, of course, we need x squared plus 2x plus 4 here. So we have x squared plus 2x plus 4 here. Use a couple of parentheses to make sure. Okay, so we're going to have up here ax plus b times x plus 3. And we're going to have c and x squared plus 2x plus 4 all over our denominator. Now, to be correct, write out the right-hand side of the equation. That's a little tedious. There's a way to shortcut this, but I don't want to do that right now. Okay, so it's x plus 3, not x minus 3. So now, denominators match, the numerators have to match. So we're going to write out ax plus 3. X plus 3. Plus 3 times x squared plus 2x plus 4 equals 3x minus 5. Okay. So numerator. We could think of multiplying through by the common denominator, which we could have done earlier, but we said okay. We now use a distributive law. And we get ax squared plus bx plus 3ax plus 3b plus cx squared plus 2cx plus 4c equals 3x minus 5. You can check my algebra there. Use a distributive law to multiply these. And simple. Distribute the multiplication by c through the quadratic expression. And we have this. Now we want to arrange this with the c squareds or the x squareds together and the x's together. And things don't have x together. So that's something new. We've got x squareds, so we're going to have to deal with those. We got a x squared plus cx squared. And then we've got x. We've got one here, and there's going to be one here. So we've got bx plus 3ax plus 2cx. And then we're going to have constant terms 3b and 4c. That equals 3x minus 5. We've seen that, put these in parentheses, put these in parentheses, put these in parentheses. Don't have to do that, but it's easier to see what's going on if we do. And I guess we have to have a plus in the 3a. Okay. So now we factor out our x squared here. We factor out our x's here. And then we have our 3b plus 4c in terms of our x's here. Okay. So now we ought to be able to write down 3 simultaneous equations. We'll give you a couple of minutes to see if you can do that. From this form, what are your 3 simultaneous equations? Okay, let's get these 3 equations. There's no x squared over here. In order to have no x squared on this side, a plus c is going to have to be 0, isn't it? So to get our x's to match up, well, this b plus 3a plus 2c is going to have to equal 3. To get the negative 5, we're going to have 3b plus c equals negative 5. Now let's write these equations out a little more explicitly. Well, it's a form that allows us to see how the variables line up and make decisions about what multiples of which equations to add to which. Let me have this over on this way. Let's see the equations here. So we have A plus C equals 0. Leaving space for B, which we don't have in this equation, but we're going to have these in the equations below. So we're going to want our variables to align. Okay. So we got B plus 3A plus C equals 3, right? Now, changing the order, we got 3A. We can 3A plus B plus C equals 3. Now we see immediately it's going to be pretty easy to eliminate C between these two equations, right? And since it's just a 1C here, it's going to be easy to eliminate C in any equation. Equally easy to eliminate A if we want to. But since it's just 1C and 1C, we'll probably choose C. Then we have 3B plus C equals -5. Well, you know what? This comes out pretty nicely. If we subtract the first equation from each of the other two, C's are going to go away both times, right? And we're just going to have two equations of A and B. So that's going to be easy. So let's do that. Okay, so if this is 1, 2, 3, we do 1 minus, let's do this, let's do 2 minus 1. We can do 1 minus 2 or 2 minus 1. If we do 2 minus 1, we're going to end up with positive coefficients, and that's a little bit of an advantage. Okay. So I'm not going to write out the details of that. That's very simple. We do the 3A minus A, we get 2A. We get B minus no B, so we just have B. And then that's going to equal 3. Equation 3 minus equation 1 is simply going to give us 2B equals -5. That makes things really easy because we now are going to know the value of B, right? Just plug that in here, we get the value of A. Once we got the value of A, we can figure out C real easy, or equal and opposite to 0. I said that kind of fast. You might want to play this back slowly. Check out the video, but so we don't have to do any more adding multiples. We can immediately solve this for B. So we get B equals -5/2. And we plug that back into this equation, which gives us 2A plus -5/2 equals 3. I don't want to deal with fractions, so I'm going to multiply both sides of this equation by 2. I'm going to get 4A minus 5 equals 6. That just clears my fraction, makes it much easier to solve. 4A then equals 11. A equals 11/4. And now I've got a value of A as well as a value of B. I don't need both values. Notice that once I've got B, since A is missing in this equation here, I could have solved for C right away. But I decided to wait until I have my value of A. There. I decided to wait until I have my value of A because it's even easier up here. Okay, so A equals 11/4. And go into this equation. switch from that and tell me that A plus 11/4 equals 0. Sorry. 11/4 plus C equals 0. So C is negative 11/4. So this is a particularly easy set of three equations to solve. Okay. If my numerator over here had been a little more complicated, it had an x squared and an x and stuff, then the three equations wouldn't have been quite as convenient. You wouldn't be missing B here, you wouldn't be missing A here. Nevertheless, those are the algebra details. And that should put you in pretty good shape for solving these partial fractions questions. Okay, somebody just pointed out an error here again. A little bit careless. We got 2C here, right? I've only got a C. It should have been a 2C, right? So that's going to change the solution. So this is going to have to be 2C. And well, that changes a lot of things, okay? So all this is based on my failing to copy this correctly. So there's not much I can do to fix that right now, but the procedure is correct. Solution's a little less simple, but not much. I would then choose to subtract the third equation from the other two. Or multiple of the third equation in this case. Okay? Or add a negative multiple. Still going to be a simple solution.